All right, everyone. Welcome to another weekly webinar. Today, in our inspection series, we're going to talk about insulation and what we need to be aware of when we go out to inspect insulation. Now, what I will say is, for me, I always feel like the appropriate concept that you need to have is really you need to inspect what you expect. I have a set expectation of what I want to see when I go out to inspect. And by having this established expectation that I let everybody know what I'm wanting and what I'm looking for. And remember, it's not always what you say, but how you say it. I'm not a mean person. Everybody always says, "Oh, Hope's going to go out and do a insulation inspection. I feel really bad for them." And it's like, why? It's one of those opportunities that, if they have room for improvement, I get the opportunity to hopefully provide them with that little bit of knowledge that next go around, they'll have the opportunity to improve upon it. But I do have a very set expectation, and that is known with many of the builders that, when I go out and I inspect projects, that they know they have to have all their ducks in a row. Ducks as in ducks, not ducks, in a row to ensure that they're going to be able to pass their inspection. Now, today is probably going to be a little bit different than maybe some of the other ones that we've done where we provide you with a lot of information. Now, you guys have always been really good about interacting with us, but today we're going to show pictures. We're going to allow people to take a look at those pictures and offer their insight as to what they see, what they don't see. Maybe there's something that should be improved upon, but it gives you the opportunity to do that. Excuse me. Whoops. So, when is a building commercial? So, to know whether a building is commercial or residential, we have to look in the code book. And the code book says that if you are a residential building, if you are a detached 1 and 2 family dwellings, or you're a multiple single family, meaning townhouses, right? Or you're an R2, R3, and R4, and you're 3 stories or less, you might be building out of the IBC, but you're going to do your resident or your energy out of the residential side of the book. Now, it also says anything that doesn't fit under the parameters of a residential building is then considered to be a commercial building. Now, what if we have those buildings where the bottom floor is a commercial project, right? It's a coffee house, and then 2 stories above it, we have residential. Well, that falls under that lovely category of mixed use. So in that particular instance, you're going to use both sides of that code book. So the commercial portion of that building is going to follow the commercial provisions, while the residential side or the residential floors of the building are going to follow the residential side of the book. Now, as far as, how would you see something like that? How are you going to inspect to something like that? A lot of times what a designer will do, knowing that you're looking at both sides of the book, if it's required that on the commercial side you need an R20 plus 5 continuous, and the residential is only required to have an R5, then typically what they'll do is they'll do the entire building as an R20 with an R5 continuous, because it's a lot easier instead of trying to mix and match what's going on. But they would very easily have the opportunity that only that bottom floor would have to have the cavity plus continuous insulation, and the top 2 floors could just go with the cavity insulation. They do have that opportunity. And sometimes with these projects, what you'll do is you'll get a res check and a com check, and it's basically between the 2 reports, it creates a single building for it. All right, so when we go out to do inspections for the insulation, we have to realize that we aren't looking at the values that are in those tables. The only time we look at the R value of the table is if they are going with the prescriptive R value, or the U factor. But the U factor, they're going to give you their assembly on how that is going to be. Otherwise, if they're going ComCheck or total building performance and utilizing some of the compliance paths in ASHRAE, there's a report, and that report is going to let you know what insulation values are going on with that particular project. Now, the same can be said when we're talking about, excuse me, when we're talking about the residential compliance path. There are only a few compliance paths that have a report. Otherwise, you would inspect to what we would find as far as those R values. Now, here is that lovely screen that we've all seen with the various types of insulation and their R values and what we would typically get. And here are some of those other styles of insulation that are probably getting utilized a little bit more often than they have been in the past. Sheep's wool seems to be a pretty popular one. Rock wool, you'll see rock wool a lot when you start talking about like fire resistant rated construction. And hemp is starting to kind of make its way into the field a little bit more. And that's because of its lack of fire properties, or lack of, yeah, I guess that's probably the best way to do it. All right. Now, insulation is no different than any other type of item that's getting placed into the project, right? If it's a material, if it's equipment, if it's an appliance, all of that has to be installed per the manufacturer installation instructions. And for insulation, that's the same requirement that you're going to find out there. So insulation actually is required by the manufacturers to be installed per a grade 1 installation. Now, what you see on the screen here is the grading system. They all have a grade 1, grade 2, grade 3. This is the standard to deal with the BAT insulation. So basically for a grade 1, which is required by the manufacturer's installation instructions, is it goes from side to side, top to bottom, and then you have it from, back to front. That's our 6-sided encapsulation. And within that 6-sided encapsulation, we have to ensure that it's not compressed. If we have piping or wiring or something of that nature, we got half in front of it, half behind it. If it happens to be an electrical box and with BAT insulation, they want you to cut it and do it when a lot of times what I see is they seal up the back and then they're placing a piece of insulation uncompressed back behind her. It's not getting that R20 that would be required by code, but it does give a little bit more thermal resistance there. And then for grade 2, as you can see on the screen here, it's not too bad, but this stud was a little wonky, right? And so it caused a compression on this one. And they did try to cut the BAT to fit that narrow cavity. And so they definitely tried. It's not a grade 3, but it's not a grade 1. So it falls into that grade 2 category. And grade 3 is just a horrible install. And basically I'm kind of on the, you need to pull it out and start over because it's not doing the job. It's just a wasted material and a wasted, money being done for this project. Now, BAT insulation, you can't put on the plan saying, hey, I'm going to put an R38 in a 2x4 cavity and BAT insulation will magically fit. BAT insulation is really dependent on the thickness of that space that it has to occupy to ensure that it will reach that R value that is intended. So to get an R20 utilizing BAT insulation, you have to have 5.5 inches. And it doesn't matter what the plans say. The plans can say an R20, but physics and reality is you won't get it out in the field. And if it's not getting done out in the field, then you end up where the equipment is not being sized appropriately because the thermal envelope is not as it was intended to, how it had been designed by the architects. Now, for all of us, insulation inspectors or just inspectors altogether, right? The code really does try and gives us so many tools to assist us to ensure that we are able to do our job. And one of the things that the code says, if we go and look in chapter 3, a lot of people only look in chapter 3 to find out their climate zones, but there's actually further information, some really valuable information in there. And one is that the insulation has to have an identifiable R value marking on it. And this allows us so that when we are out doing our inspections and we're walking around, that we can say, oh, okay, that is an R19 in the wall, or that is an R15 in the wall. And we're not having to like dig and try to figure it out. It allows us basically to include that insulation requirement with another inspection that we're doing because it's readily available for us as we go out. Now, if you look at this project here, we got an R19 here, an R19 here, we got an R19 here, but in this bay, it did not have the marking of an R19. And when I went out to do the inspection, I did not fail the inspection. I did pass it because all the other bays did demonstrate that they had an R19 being installed. But the reason why I would install it is, one, I had a good relationship with the super and they had never tried to pull like, you know, a quote unquote fast one on me on it. The other thing is when you look at the install of this particular bay, when all the other ones are 19 and this one is here and the insulation is basically at the same depth as all the other insulation, I can deduce that it probably is an R19 that's being installed there, and I'm going to call it good. But where it does become troublesome for us is when we look at like blown in insulation or spray foam insulation. It actually does not contain that little magic R number that shows up and says, oh yeah, you got an R20 once it all, you know, dries out. So at that point, you would have to have an insulation certificate. So it would be, this is what we would see, which again is in section 3 or chapter 3. And it says, you know, if it's blown in insulation, we got to know the initial R value, the initial thickness, the settled. That lets us know of what we're expecting from it. The spray foam has to tell us what thickness and R value it was installed in. Now, a lot of times we get this at the end of the project. They have to provide it for us for our records as far as getting that certificate of occupancy. But the reality is at that point, we're so far down the road that nobody is going to go in and say, hey, you installed an R11 instead of an R20 in that wall, and now your mechanical equipment isn't going to work right. But if we're out there and they had just installed that insulation and they place that certificate saying this is what I installed, or a ticket, I just call it a ticket. It's usually a ticket. It's stapled to the stud or it's taped to the stud, whatever the case may be. And usually I get one per room. I might get one on each wall, but usually it's one per room. And I'm okay with that. At that point, if they installed an R11 instead of an R20, we can sit down and have the conversation and rectify that long before we're, you know, later on down the road. Okay. The other thing that I'm going to say is when I go out and I do inspections, I look at the ground a lot. And the reason I look at the ground a lot is because the trash on the ground actually gives me more information sometimes than what I'm going to see or hear from, the contractors or what I see, out in the field. And so this happened to be, this project was required to be, have the walls as an R20. And I'm walking over, bag after bag after bag of full R13, plus I'm seeing empty bags that are R13. So they had been installed. And when you looked at that 2x6 wall, there was a significant gap from where the edge of the insulation was until the edge of where the face of the stud was. So you could tell that it did not fill up 5.5 inches. It did, the 3.5 inches that an R13 would do, right? So that's a problem. I look at the ground a lot. Yes, I know I've had people say, are you trying to make sure you don't trip? And yes, I am trying to make sure I don't trip, but I get more information sometimes, like I said, from the ground than I do, having those conversations. So the other thing that when we start talking about this, that we have to be aware of is this space or room part of the thermal envelope? Are they inside the thermal envelope or are they outside of the thermal envelope? And we have to be fully aware of it. If it's a crawl space or an attic, is it being vented or unvented? Because that's going to let us know the location we should be looking for the insulation to be placed. If it's a garage, it's dependent on, are they conditioning that garage? If that garage is getting conditioned, then we have to pay attention to all of the garage walls and the doors and windows and roof or floor, depending on, the design of the garage. And we have to ensure that it meets the requirements of the thermal envelope. Now, typically a garage is only getting heated, and it's only getting heated for a small number, like, up to 50 degrees. And the idea is that they're trying to melt the snow and ice off of the car and not allow it to pool up and become ice on the garage floor, that it moves to the drain or slopes out of the building, whatever the case may be. And that's what will happen, with that garage. Now, the older codes don't have it, but the new code in the 21, I think in the 21 it has it, but definitely has it in the 24, where garages, if they're being conditioned, they don't have to go with that full-blown R30. They actually only have to be insulated. The walls only have to be insulated to an R13. And then the ceiling only has to be insulated to an R24. So it gives you a break, understanding that basically you're kind of like a semi-heated space, and you're not heating it all year round either. Oh, and then fuel burning rooms, right? So if you're bringing outside combustion air from ductwork located in the, the high-low situation, where you're dumping that combustion air that is coming directly from the outside through ductwork, metal ductwork, and dumping into a space, not going into the equipment itself, but just into the room itself. At that point, you have to either thermally isolate that mechanical room, or you're going to have it completely outside the thermal envelope. So at that point, if this didn't have sealed combustion going on with it, then the insulation that we see here, we wouldn't necessarily care so much about, but the insulation back here we would, because that's part of the thermal envelope. But if the combustion air was being dumped in here, then we're going to want to thermally isolate that room. All right, so attics, are required to have these markers in it. And the markers are there, when you have like that blown in, excuse me, insulation, and it lets you know what the depth is as far as how much insulation that they blew in. Now, I am one, and it drives the builders nuts, but I get up into the attic, and all of them have to face me. I'll test the one right by the attic, and then I go over a couple of bays and I test that one to see, to ensure that it, you know, like in this instance on the bottom, that it is actually 10 inches of blown in insulation. Now, another thing to be aware of is we don't always just have a flat ceiling line. Sometimes we have those architectural features, and this isn't necessarily just a residential feature. We have that all the time on commercials, commercial projects too. So we have to pay attention to that. And we have to ensure that we get the full depth of insulation over this part right here, because one of the things that we can do for that is have these insulation dams, because if we're blowing in the insulation, these little pieces of whatever, I've seen lots of things being utilized, but plywood, OSB, thermoply, anything of that nature that keeps the insulation in its location allows that we have a better shot of that full depth, you know, pretty much all throughout that architectural feature. Now, are we going to have, you know, may not be fully right here, but you're getting a much better job, because if we went back to this one, what would happen is that blown in insulation would just slide down. So we'd have no insulation up here, and then we'd have it piled, you know, right here. And that's not good either. Now, I also have the conversation about if you're going to use batt insulation in this particular instance, what I suggest is, you know, you take the, if it's the long pieces, you take it in half. And at the halfway point, you're at the middle here. So half of it goes in this direction, half of it goes in this direction. And hopefully it goes from one side to the other, because that would ensure that it actually will stay in place. If it isn't going to be able to stay in place, you still have the possibility that it will slide. So I do pay attention to things like that. Now, just real quick on the commercial side, for the roof insulation, it does require, depending on which edition of the code you're on, that you have 2 layers installed of the insulation. And part of that is to ensure that we don't get water into the system and we don't get air going into that assembly. You got to stagger all the joints and seams. Now, in the older codes, it doesn't say you have to have the 2 layers, but if you have 2 layers, you better stagger those joints and seams. Now, the other thing you have to pay attention to is there's going to be various thicknesses of that insulation, because we have to taper that insulation to allow the water and moisture to drain off that rooftop. We don't want standing water on top of our roof. So if our requirement is to have an R30 continuous insulation, then I would suggest that you go with that R35 and just say R35, you know, tapered, you know, R30 average, something of that nature allows me to know, okay, so we can do it. Now, technically the code does say, hey, you got to do all the math for it. I think that not the whole roof is not going to be nothing but, you know, drains going on. There's going to be thickness, there's going to be drains to it, but you're going to have more thickness than you are drains. And I think that's a simple solution that would make a lot of sense. All right, so the next one, okay, there we go. The next one is dealing with metal buildings. So metal buildings for their roofs are required to have a system to it. You got to have that vapor retarder at the bottom, and then you'll have some sort of banding that keeps it in place. But that vapor retarder will ensure that, and you should not see any purlins. It's basically hiding all the purlins, but it's to ensure to keep the insulation between the purlins, basically, you know, kind of where we want it to be. And it allows for that, you know, kind of 6-sided encapsulation. But basically, you're going to have insulation between the purlins. You're going to have insulation that goes over the purlins. And then you're going to have a thermal block that goes on top of that second layer of insulation at the purlins location. Now, if they don't have the thermal block, then they have to go with that U factor, and they can't do the R value one. So that means all of the project has to go U factor. And if you love math, you know, like I said, that is the compliance path option for you. Slab on grade insulation, excuse me, insulation, if it's a commercial project, 24 inches or less. Residential, 12 inches or less below grade requires slab on grade insulation. It can be on the inside, the outside. You start at the top of the slab and extend it down for the distance or whichever configuration you're going to utilize. If you have a heated slab, you got to have an R5 insulation over it, or I'm sorry, under it, to ensure that the heat goes in the direction that we want it to go. Now, what we're going to do is look at some pictures. Everyone should, you know, participate. I unmuted. So you can throw out your answers or comments, or you can type them in the chat, however you would like to participate. It works. So I'll start us off. So if we look at this picture, we have a cantilevered floor. That cantilevered floor not only has to have insulation in it, it also has to have an air barrier with it. But the important thing is when I went out there, I'm looking at it, and what are the things that you might notice with this picture? You can unmute yourself. You can throw it in the chat. So in this, you'll notice when you have a cantilevered floor, you do have to have an air barrier. And a lot of people think about that air barrier that's at the bottom of those joists, but you also have to have an air barrier that blocks where the conditioned space and that cantilevered floor is, to ensure that we don't have air going in there, right? Oh, let's see, the cutouts that will be used to blow in insulation. You're right. That's the other thing I noticed, is that we've got diamonds. Now, typically the diamonds in this fashion usually indicate that we're going to do some spray foam that's going to be blown into there. Now, it doesn't always have to be. They can do blown in cellulose, which I do see a lot too. And in the later editions of the code, the really nice thing is, for this floor, you are required to have the insulation in constant contact with the subfloor, right? And so that's really kind of difficult, you know, in this type of situation, especially if you're only blowing in an R19. That insulation is going to rest down here and probably fill about here. So that means right here, you have a break in your thermal envelope. Now, in the later code, or in the earlier codes, in the 21, maybe in the 18, but 21, 24, it comes out and says, hey, if you extend that wall insulation down, you can take this insulation that's here and just rest it on the gypboard or the soffit material, whatever it will be, and we're going to call that good. Oh, you guys cannot see my pointer? Okay. Oh, now you can. Okay. I apologize. I'm at a hotel and I keep having a little bit of technical issues. At least this time, the slides are showing, because I had an issue with the last webinar that slides weren't showing. So it's hard to talk about, you know, some of these pictures if you don't have the pictures. Just imagine, right? So the other thing is, because again, I pay attention to what's going around on me. This building and the building on the other side of it was getting spray foam. So this is probably going to take care of that, because the spray foam will ensure that we get, you know, the R value we need, the insulation, but we do have to pay attention because it's got to be in constant contact with that underside. Now, in this particular image, they did a really good job. You can see that we've got our markers. They're all here, and the attic access opening was over up here a little ways. So They have a nice little architectural feature of a roof design, but the reason why I took this picture was not necessarily for the markers. I mean, I'm really happy that they had the markers, but what they did do is create this insulation dam to ensure that they had a better possibility of getting insulation to the full depth. So it wasn't, sliding and not, outside of the realm of what we would like for it to be. Now, here's one where they didn't do too bad. They have some good spots, some bad spots, and most of their areas that they can improve on really has to do with that narrow cavity. Batt insulation is incredibly difficult to cut, right? I don't know if anybody's had fun trying to cut batt insulation. Now, somebody has told me that rock wool is easier to cut than batt insulation. Don't know. I haven't tried the two to compare to see if rock wool is any different than the batt insulation, but they did have some issues with the more narrow cavities, and I'm not sure what they're doing right here. There was a gap, so they stuffed some insulation in there. Now that insulation is not going to do anything for the thermal resistance, and it's really not doing anything as far as an air barrier, right? Because the batt insulation is air permeable. Now, the other one is looking right here. We've got the framing between the space between the framing and the window. Now, you do have to seal that up. Cannot see the pointer again. Okay. You do have to seal that up, but you cannot utilize air permeable insulation. So you can't use that batt insulation there as air barrier material, as air sealing material. You have to have something that's air impermeable. Now, real quick, because I know we all have to deal with commercial too. A lot of times I will see that insulation will be installed great, but it stops right here at the bottom of the beam. So I always have to go in and look and feel behind the beam to ensure that it continues and extends all the way up. Otherwise, we have a break in that thermal envelope. So what do you guys think about this one here? How many of you say this is a grade 1 installation? How many of you say it's a grade 2 installation? How many of you say it's a grade 3 installation? This is a grade 3 installation for many reasons. One, you remember when I showed you that R11 installation or maybe I didn't, but there was a bag of R11 insulation. This is a 2x6 wall. So when you look at it, the insulation truly was an R11. And what they were doing is they were installing it and pulling it out to give the impression that the cavity was full of insulation instead of having that 2.5 or that 2-inch gap. But you can see the difference right here on this face of the stud. You can see it on many of them. And that's honestly, I do think that that's probably why the install was so poor, is because they had that R11 that they were trying to make it look like an R20. In this particular instance, I had a jurisdiction. The inspector goes, can you come out? I said, sure. He goes, I don't think they're doing it right, but I don't know what they're doing. I said, sure, I'll come out. And as soon as I came out, the super was very, very quick to come out and let me know that he knows what he is doing. He says, we're in climate zone 4 and it's not required to have an air barrier. I'm like, well, one, this is climate zone 5, and even in climate zone 4, you still have to have an air barrier. The only climate zone that is exempt from an air barrier is 2B. But then I come out here and I look at this. that wall was supposed to be an R19, and R11 is a significant difference as far as insulation and the performance of that thermal envelope. Now, if we looked at this one, it's actually a pretty good install here. The only problem is we have no idea what the R value is for it. And that's because we don't have a certificate. They did not have a certificate on the wall. So we don't know, you know, is it a open cell? Is it closed cell? I mean, we have our suspicions as to what exactly it was. And, you know, and how much insulation is this? So there were a lot of missing variables that we really needed to ensure that this project was doing everything that it could do. Now, what do you guys think about this one? How about this? Can you guys see the sheathing exposed right here? So not only is it that we can see that exterior wall sheathing, oh yeah, we got that exterior wall sheathing that's exposed, but look how much depth of the joist is also exposed, right? Now, if you're at an R19, you might have that significant amount of a depth for it, but this happened to have a requirement that it had to be, I can't remember if it was an R30 for the floor or an R38. Oh, no, no, no. This was for the, they had a occupiable roof for this townhouse. So this was that townhouse. So it had to have an R49. It does not meet the requirement of that R49. There is, you know, the walls behind fireplaces, they are still part of that thermal envelope. And a lot of times they might be bumped out, but they are required to still have insulation, you know, placed behind them and an air barrier behind them. So in this particular instance, and I see it a lot, they'll just spray foam it. And honestly, there's nothing wrong with that as long as it works with, you know, how the fireplace is staying, you know, saying for combustibles and all of that fun stuff, and you comply with it. So if you look at this image, you'll notice that half of the ceiling has spray foam and half of the ceiling has batt insulation. Now, when you look at this, what do you think is going excuse me, what do you think is going on here? Anybody have any thoughts? All right. So in this particular instance, it actually is, excuse me. Wow, that really bothered my throat. So it actually is doing two things. So what we are going to pay attention to as inspectors for the insulation is what's going on with this spray foam, because the spray foam that we see on the screen is part of that thermal envelope. If we go into 2604 of the building code, the IBC, it talks about when you have foam plastic insulation installed, you have to separate that foam plastic insulation from the interior side of the building. And you do that by having an ignition or thermal barrier. So this is one of those times that I just happened to be there at the right time where it was kind of like that before after image. And so the before is the spray foam, which is what I would need to know. And the batt insulation is there as the thermal or ignition barrier. So that's why we have the two. We don't care about the, I mean, we care about the install, making sure that it's there, just that we don't care necessarily how it's installed. Is it compressed? If it's compressed, in this particular instance, it's not part of the thermal envelope. So it's not something that, you know, I would get bent out of shape about. Now, in this particular building, one of my builder friends, he actually builds his houses. This is in climate zone 7, and he utilizes a heat pump, and they're at like 14,000 feet, which is very difficult because it's very high elevation and it's incredibly cold. But because of how he designs his structures and pays attention to it, a single heat pump is able to heat that structure and heat it incredibly comfortably. So he installs an R20 continuous insulation on the exterior, and you can see he has furring strips going on so that he can attach the exterior cladding. I know a lot of people are incredibly concerned when it comes to things like continuous insulation and dew point and structural integrity and exterior cladding. But when it comes to the exterior cladding, most exterior cladding manufacturers have requirements, and they'll say, you know, if you're going to install an inch of insulation or an inch and a half of insulation, you do this. And then if you're installing where the insulation is like up to 4 inches, then you're going to have like furring strips. The furring strips need to be every, you know, whatever the case may be. And that's what he did. He had to submit it as an alternative method, means, and material. But it definitely works. Now, the nice thing is now in the 21, it gives you the opportunity to have just continuous insulation. And it's so funny because people were freaking out that the cavity didn't have any insulation. So he put like an R11 on the interior side so that people felt more comfortable, because they want to see the pink in the wall, so to speak. But the heavy lifting was dealing with that continuous insulation. And as far as the, you know, the concern about like that dew point, think about if you have like a glass of iced tea or a Moscow Mule. The condensation doesn't happen on the interior side of that glass. It happens on the exterior where the cold is coming into contact with that heat. And that's where you're going to have it. So that dew point actually is outside of that wall assembly. All right, how about this one? This is Ruffles, because this insulation is very stylish and wants to be, you know, up in the fashion world. That's my, I'm trying to be funny picture. Some people said that I wasn't very funny, but that's okay. It made me laugh. So here's a slab edge insulation. I was going out with the building official, and he was very, very proud because this project was going with a net zero energy. So they had chose to go net zero, and he was all excited about it. And, you know, I came out because I was visiting him. He's a good friend of mine. And we walk up to it, and he's like, "Don't look." And I'm like, "I already saw." Because right here, if you notice, there's a huge gap of where that continuous or that slab edge insulation should be at. And it's not there. And the slab is still, you know, like 12 inches. You saw and took the picture before the comment. I do that a lot. But this time I didn't jump out of the car, Guadalupe. I have been known to jump out of the car. So I know we don't cover existing buildings, but one of the things that, you know, we do have to keep in mind is when you are like replacing siding and putting new siding on, you can't make the building any less energy efficient than it was. And if you see the image on the screen, you might notice that it's kind of a, what do I want to say, a hodgepodge of items, I guess you could say. Nothing is very consistent because we see that this bottom level has Tyvek, the level up above it has house or felt, and it's ripped felt. And then we've got sections that has continuous insulation and sections that have Densglass. This is not ensuring that the structure is maintaining its energy efficiency that it had previously. It's making it obviously less energy efficient. This is in my hometown that I live in, and this was a long time ago, when the old building official was there, not the new building official, and it showed the picture, and they knew exactly what building it was because that outline, everybody knows what that building. That's our Elks Club. So he goes, "We do better now," and I'm like, "I know we do better now. We've had many a conversations. I know we're doing better. This is just a reminder, right?" How about this one? What do you guys think? Is the install good? Raise your hand. Oh, ouch. If you think the install is good. Okay. Raise your hand if you think the install is bad. Raise your hand if you're not really sure and you want Hope to tell you the answer. All right. Thanks for being honest, Guadalupe. So actually, when it comes to this, because this is just part of that facade, they are putting the mineral wool in there, but it's not part of the thermal envelope. This happens to be part of their fire resistant rated construction. So I'm not concerned about how that particular install is happening. Now, here's a tiny home, and here is an example of the floor that was installed. Now, remember, the floor, the insulation for the floor has to be in constant contact with the underside of the subfloor, unless you're on one of the newer codes, which allows for it to be placed where it's placed right now, as long as you bring down that exterior wall insulation into those cavities to ensure that we don't have breaks in that thermal envelope. So this one, you look at it and you could say, okay, there are so many issues with this one, or you look at this one and say, okay, you can have the insulation there, but we got to bring down that wall insulation. So that becomes a conversation, or that becomes, hey, what are you going to do here? Maybe this is the, excuse me, what we're seeing is the bottom of the floor, and the insulation is actually installed above or at the where the subfloor will be. But it is a conversation to have. All right. So if we looked at this, this is again one of those situations where it's a flash and bat system, meaning that they sprayed that rim joist with, sorry, I've been talking and teaching all week. They sprayed that rim joist with spray foam. So it has to have an ignition or thermal barrier. So we have, what we're paying attention to is the installation of the spray foam, and not necessarily like the compression of that bat insulation, because the bat insulation is just there as that ignition or thermal barrier. How about this one? What do you guys think about this one? Raise your hand if you see an issue with this particular image. Okay. Raise your hand if you don't see an issue with this image. Okay. Raise your hand if you think you have the answer, but you want to know what Hope says before you confirm. Okay. So what we have here is we do have a break in our thermal envelope, because I know you can't see it because I didn't take the full picture there, or I didn't put the full picture in here. Down below here, we have spray foam. Now we have an unvented attic, so the spray foam is going on that underside of the roof sheathing. The problem is, and what we really have to ensure is that we have insulation at that top plate. So right now with what we see here, we have an enormous break in that thermal envelope. Remember when I say I should be able to trace it with my finger without lifting my finger? We have a lot of finger lifting going on in this project. So this one, they needed to fix a whole lot of things to ensure that that continuous insulation was continued on from that top plate to where that insulation for the underside of the roof sheathing. Now I've had people say, but then it goes into the soffit, and it's like, you're right. There is a possibility that some's going to go in there, but it doesn't matter. You're not venting this attic space, so you're not blocking any air movement from happening. And in fact, we need to block the air movement from happening here. All right. What do you guys think about this particular one? How many of you say we are good? All right. How many of you say we are not good? Yep. Those that you raise your hand on the not good, I'm sure you guys all immediately, because you guys know this, saw all the, through holes, not just like little pockets every once in a while, but the through hole here. We got some here. We got this here. We got this here. We got here. We got here, 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 here. And this was a good wall. Now, what do you guys think about this installation? Do you guys think that this one is an okay installation? Okay. How many of you say this is a good installation? Raise your hand. How many of you say it's a bad installation? Raise your hand. How many of you aren't sure and would like for me to give you the answer? All right. Honesty, that's always a good one. All right. So when you first look at this, and I'll admit, when I first was looking at it, sometimes, you look at something and you move on, but something in the back of your head is kind of nagging at you and you can't figure out why or what is nagging at you. So then you go back and you look and you're like, okay, 2x6 walls, we got spray foam going on there. They're going to hit that R20 requirement. But then you take a look there. What they had done is took those foam paddings and placed that in the cavity and then put spray foam over it. Now, I'm not saying that you couldn't potentially do that, but that was not the design that had been called out on the plans. And so that was one of those times that I was like, huh, okay, that seems like, I'm glad that something poked in the back of my head, because I'll ask you, if I had said, this is what I saw without having a picture, how many of you would have believed me? Yeah, no hands are up. I think people would have been like, yeah, sure, right, Hope. That's what they did. I have a lot of those, but so here we go. Here's one where we had a lot of issues. The building department caught it all, said, and talked to them about it. So it was getting addressed. They had some issues because sometimes, even though it's really warm outside, the equipment might have been cold and it didn't spray the foam correctly. Not necessarily operational error, but equipment error. And in this one, this is where, I'm going to show you a great example. So I'm walking over this insulation, R11. It's that lovely brown marbling. I'm seeing it installed in the walls and not very well, as we talked about. And the plan's called out for an R19. That is a huge issue as far as, like how your mechanical equipment is going to work. And this was a multifamily project. So these apartments are going to be incredibly cold, incredibly cold. So in this particular instance, can you guys see the highlighter or the pointer? I hope you can, because I'm going to use it. So right here, corners, like I said, corners are, when we talk about slab edge insulation, are quite often the area that I don't want to say is missed, but just not installed to the fullest extent that it should be installed. So as you can see here, we've got a gap at this corner, and this slab edge insulation should have extended the entirety of that wall. And if you notice, the backfill is already up and there's no insulation there. So that insulation is demonstrating that they did not install it where it was all supposed to be. And this is a coffee shop, so you know darn well Josh and I want this to be to its fullest extent. All right, so all of this discussion is really to bring us back to like that first concept that I was talking about, which is inspect what you expect. Like I mentioned, you know, in my story there, that when you have an established expectation, the builders know what is expected of them, and they really do, you know, in my opinion, they do really provide that. But if they don't know, they're going to do what they've always done. So I have a very specific expectation about when I go out to do inspections. Now, that doesn't mean that I'm mean, right? Well, I'm not intending to be mean. It might, people might think I'm being mean because I tell them no, but I'm not telling them no to be mean. And I usually talk to them about what they can do to improve it. Sometimes it's, okay, so on this next project, you have the one next door, let's get it right. These are some fixes that you can do. And I know we're not supposed to, design it for them and what have you, but really the reality is that homeowner, if it's, a home, is expecting that one, they can heat and cool their home, and that they can heat and cool their home without spending an arm and a leg to do that. And that's what we're here to do, is really to ensure that our constituents are really there and can fully utilize what's been provided for them. So I just wanted to remind you about the website here. Here's the link to it. And if you go in, there's resources for the 15, 18, and 21. As I had mentioned before, you can take a look at, some of the things that are in here, and there's spray foam insulation, what some of the requirements are for that, the ignition and thermal barriers. So that is available on there. And of course, as always, please feel free to reach out to Josh or myself. And we're always here to answer any questions or anything of that nature. And just so you know, we are trying to get that next building community coffee event up and going. We had a little bit of a letdown. I don't know what you want to call it, but we will get that up and going. And as soon as we're able to find the replacement location, we'll let everybody know. So with that, I will talk to you all later. Have a wonderful week, and you get me again next week, and we're going to talk about entrances. So with that, I will talk to you later, and you have a wonderful, wonderful Thursday afternoon. Bye, everyone. And stay warm. I know you're all warm, but here it's -8 degrees. So enjoy the warm weather. Bye, everyone.